crystal, there's 126 sodiums, and there are 126.
All right, friends, what is the basic premise of collision theory? In order to react, particles must collide.
Sense, then, for this crystal to write the formula as Na126 Cl126? And then this one over here, would it make sense to write it as Na?
That is the basic idea, okay? That's the start of collision theory.
And then
what is a successful collision?
Would have like a different number of ions. And you'd have to write a different number.
Yes, that's one of the things necessary. That's going to be one of the answers to number 4. Okay, which is what is necessary for a collision to be successful. But what do we actually mean when we say a collision has been successful? What does that mean?
Ions in this crystal?
It actually reacts. A successful collision is a collision that results in a reaction.
Instead, when we're dealing with a crystal lattice, because the crystal can be big or the crystal can be small, when we write the formula.
Now, if you're not used to my abbreviations yet, I have a tendency to make anything that's like a shun, like a little N up at the top. So N is collision, okay?
Whole number.
And if I ever write down anything and you're like, what on earth do you mean, Ms. Spence? Feel free to put up your hand and say, what on earth do you mean, Ms. Spence? Okay, I'm not, I have a tendency to abbreviate without even thinking about it. So if you don't know what it means, just let me know. What is another name for a successful collision?
In sodium chloride, there's one.
We could also call it an effective collision.
We simply write the formula as NaCl, no subscript.
And now we're going to get to those 2 things that are necessary, okay, for a collision to be successful.
This is where I got to with my other
class. You had at least one of them
the other day. So we're going
Which
to
one did you want to say?
At this point.
Correct geometry.
I'm going to let you know what we're going to be doing for the rest of the class. Okay? So
tell your partner, what do we mean by geometry?
Is you are going to brainstorm with your neighbor and the people around you a vocabulary list, not just from this section, but from all the stuff we've done.
What do we mean by geometry? I want to hear, like, I want this to be interactive. Can you imagine if you went up to your friend during the day, and I'd like to think that we're, you know, I've just met some of you, but I've known some of you a while.
Okay.
Can you imagine if you went up to your friend and you're like, how are you?
The second thing you're going to do.
They just stared at you. Maybe with a smile on their face.
Once we have a class list,
right? Would it be weird?
We're going to
it would be weird. So
creating a visual dictionary
saying,
for yourself.
What does geometry mean? And then you just stare at me, maybe with a little smile, maybe not. Like, honestly, we're just having a conversation.
And a visual dictionary would
and
include
to be honest with you, the more you interact socially, which means you're like, you know, actually putting yourself out there and saying something, the more you are using those neurons in your brain that have to do with speech and that have to do with social interaction. So that means that you not only have your written output neurons, you don't just have your reading neurons, you have your speech neurons that will also help you to remember. So whereas someone else may only have 2 sets of neurons working, you can have 3 or 4 sets of neurons working to help you out. Which is one of the reasons why I have you talk with your partner, because I know it's a little bit hard sometimes to talk to me. You're afraid you'll be wrong. Can I tell you a story about people being wrong? Okay, I had a student, her name was Allison, and she took my AP chemistry course with me. And every time I would ask a question,
if you're 100%
bless her, she would answer. She would have her hand up. She would answer the question. I was like, oh, this is so awesome. Do you know what happened almost every time she answered the question?
that this is
she was wrong.
Because I'm not going to check your
Do you know
homework,
what score she got on the AP exam? It's out of 5. She got a 5
well, that sounds like something
because she had sorted out all of her misconceptions and issues. Like she just got them out, and I was like, oh no, that's not quite right, but this is what it is. And so all of those misconceptions, all of a sudden she was like, oh, I get it now, right? Whereas if you just sit there and you're like, I'm just afraid to be wrong because people will think I'm a dum-dum. Do you think anybody in here, this is chemistry 12, it's a tough subject. If you don't understand something right away, are you a dum-dum or are you just a normal human being? You're just a normal human being. There are those exceptional people who understand everything all at once, like at the very beginning, you know, bless their hearts. Like I'm not one of them, okay? Are you familiar with Tyler DeWitt? Do you remember Tyler? Tyler, on his very first university chemistry midterm, scored the worst in his class. You can actually, there's a video of him talking about that experience. But how chemistry was so important to him that he continued to study and learn and did better. So I understand, you know what, some of you are more introverted and you don't want to talk to me. Quite frankly, do you know what? I am an introvert. I am a capital I introvert. When I do those tests, I come out with a capital I, okay? But I can talk in front of people. It's okay. And do I make mistakes? Anyone who's had me before, do I make mistakes when I teach? I do. I make all kinds of mistakes. I drop my negative sign. I forget to write a 2. Sometimes I just calculate the wrong number. Sometimes I even just say the wrong thing. It's okay to be wrong. I want you to say it with me. Everyone? It's okay to be wrong. Everyone? It's okay to be wrong. I am okay with being wrong. Everyone? I am okay with being wrong. It's okay to be wrong in front of the whole class. It's okay to be wrong in front of the whole class. Do you think the class is sitting there laughing at you if you're wrong?
Help yourself to paper.
Or are they probably sitting there going, oh, I had that same idea myself. Or maybe I had no idea at all, right? So you guys can do it. You can do it. Okay. And you know what? Poke your friend and get them to answer with you. Then you can just like say it out loud and you'll say it out loud with a friend. All right. So what is the meaning of the word geometry? Orientation. Or in other words, alignment. So this could be like a couple particles approach like this, and we get a reaction. But if they approach like this, then we get no reaction. It just means if they're not lined up correctly. All right, correct geometry. What else is necessary for a collision to be successful? Yes? Direction. You almost could, but direction tends to mean like I'm moving this way or I'm moving that way, as opposed to this one's oriented this way, this one's oriented this way. So I would like one of those other 3 words probably, but good question, okay? All right, so we have our correct geometry. What is the other thing necessary for a successful collision? Sufficient energy. What does the word sufficient mean? Enough. Enough sufficient energy. Yes. Okay. Not enough sufficient energy. Enough energy. All right. So, do you remember, can you think back and remember any of the 5 factors that can make a reaction speed up or slow down? We got pressure or volume, so the 5 factors to change the rate. 1. Pressure slash volume. That's 1. Temperature. Yes. That's 2. Surface area. Concentration. Catalyst. And then there actually is a 6th one. Does anyone know what that one is? It's the nature of the reactants. All right, and all of these 5 things either increase the frequency of the collision, that's an up arrow. Up arrows just mean increase. Or they might increase the, what else? Energy of the collision. Or if we go the other way, they could decrease the frequency of collision or decrease the energy of the collisions. Pardon me? I'm not hearing anything except rate. Increasing the rates. These are all things that affect rates. Yes. So 5 things either do this or this and thereby increase the rate. There's a third thing. You can decrease the energy required to react. So these 3 things, let's take a look at pressure volume. Does pressure increase if we increase the pressure, which we would do by decreasing the volume, we squish it and the pressure gets higher, is that going to increase the frequency of collisions? Yes. So that one, number 1, okay? Increases the frequency of collisions. Does increasing the pressure or volume increase the energy of the collisions? That one's a little trickier. But if we increase pressure or decrease volume, we've done nothing to the temperature. And the thing to remember about temperature is actually a measure of the average kinetic energy. Okay, temperature measures average kinetic energy. Are we okay with KE for kinetic energy? Okay, average kinetic energy of the particles. So if we change the pressure, we change the volume, we are assuming that temperature stays constant, okay? You can actually, pressure and volume can affect temperature, but for the purposes of chemistry 12, we're saying let's keep the temperature the same, okay? So temperature stays the same.
You do not need to know all the equipment.
So if temperature is staying the same, are we increasing the energy of the collisions? No, because we are not making the particles move faster, okay? I'm also going to put speed of particles here because speed of particles is related to their kinetic energy. They're not identical, but if you've taken any physics, you know that kinetic energy is equal to 1/2 mv squared, and v is the speed. So as one goes up, the other also goes up. It doesn't matter. You know that if something's moving faster, it has more kinetic energy, yes? That's all you need to know for Chem 12. You don't need to know K equals 1/2 mv squared. No. Forget it. You just need to know that if particles are moving faster, they have more what type of energy? Kinetic. Okay. So we are, where were we at? We were at here, so decreasing the volume increases the frequency of collisions, but it does not increase the energy of the collisions. Does it decrease the energy required to react? No, that's like just its own little thing. We'll get to it eventually. Mostly it's going to be factor 1 or factor 2, okay? Temperature. Does increasing temperature cause an increase in the frequency of collisions? Do particles collide more often? Yes, because the particles are moving more quickly. Imagine you're in this classroom and we've emptied out all the desks. You're blindfolded, you're walking around, you'll collide with a certain frequency. But if I've then said, everybody run, you would collide more frequently, yes? Okay, so definitely number 1. How about the energy of the collisions? Will increasing temperature increase the energy of the collisions? Yes. So temperature is number 1 and number 2. We're going to ignore, again, like I said, the decreasing the energy required to react because that's something special. Surface area. Does surface area, increasing the surface area, increase the frequency of collisions? Now, I want you to think about surface area. Here, I have a block. Okay? Now, oh, hey. Where they are. Yes. I have blocks. Let's see if I can hold them up successfully.
So I'm going to let you know that my other
block
we came up with, there were
there. People in the class. I have 4 little blocks together. Yes? Can I see? Should I see if I can do a cube? I don't know if my fingers are big enough to do a cube, but we'll try. Okay, here we go. Okay. Now, you have a surface. You got 1, 2, 3, 4 things on each side, yes? So 4 centimeters cubed. How many sides on this? 6. So 4 times 6 is 24 centimeters cubed. Now, what if I split them all apart? How many centimeters on each side? 1 on each side. 1, 1, 1, 1. So there's 6. Yes? How many cubes do I have? I have 1, 2, 3, 4, 5, 6, 7, 8 cubes. So 6 centimeters cubed per cube, 8 cubes. What's my surface now? 48. So if I take my cube, my bigger cube, and I chop it up, I have exposed the inside parts, yes? So will I have more collisions? Yes, because now I have more surface available to collide. Okay? So yes, the frequency of the collisions will increase. The cubes smell nice too. They smell like piney. I think they're made of pine. Does increasing surface area increase the energy of the collisions? And when you think about energy, you need to think about speed. Does it increase the speed of the collisions? No. Okay, so just factor number 1 for surface area. Concentration. Does concentration increase frequency of collisions? Yes. Does increasing concentration increase the energy of the collisions? Okay, some 0.5 molar copper 2 chloride, and here I have some 0.1 molar copper 2 chloride. In which of these are the particles moving faster? These are both at what temperature? They're at room temperature. Okay, not at standard temperature and pressure, because standard temperature is 0 degrees. They're at room temperature.
It's okay to make mistakes, though.
So, are the particles in either of these moving faster than the other? No, because they're the same temperature. Things at the same temperature, the particles move the same speed. Okay? If substances are at the same temperature, their particles move at the same speed. I'm simplifying a little bit here. Okay, if you're in physics, you'd be like, no, if they're more massive, they'll move slower. If they're less massive, they'll move faster. We're going to ignore that because we're in chemistry and we don't care that much. Okay, we're just going to say they move faster. Okay, to be more correct, you would say they have more kinetic energy. Yes? Or you would say they have the same kinetic energy. And if they have the same kinetic energy, are they colliding with more kinetic energy? No. Okay, so pressure volume affects only the frequency of collisions. Temperature affects both the frequency and the energy of the collisions. Surface area affects only the frequency of collisions. Concentration affects only the frequency of collisions. Now, catalyst is a little bit special Catalyst does number 3. It decreases the energy required to react. So if you needed 10 kilojoules of energy to react without the catalyst, maybe you only need 2 kilojoules to react, which means that more particles will meet that threshold. Okay?
9 minutes. Well,
so catalyst is number 3. Now, to be honest, nature of the reactants, that's not something you can actually change about a reaction. You can only compare one reaction with a different reaction. But you cannot say, if this is my reactant and this is my other reactant, I know these are not going to react together, but let's just pretend. Can I change the nature of this thing? No, it is what it is. Its nature is its nature, yes? Can I change the nature of this and still have it be the same thing? No, I can't. Its nature is its nature. But what I could do is I could say, oh, instead of having a wooden block and I'm going to throw in there, I could have a plastic block that I'm going to throw in there. And that plastic block would have different characteristics. Of course, plastic and wood are not going to react with copper to chloride. But nature of reactants, this is only for comparing
solvent. Excellent.
Different reactants.
Chili. Soluble. Elijah. Covalent.
But what it does is it affects the energy required for a collision to be successful.
Mixture.
Okay?
Wonderful. Danica. Homogeneous. Also pronounced homogeneous. Either way is fine. Homogeneous or homogeneous. Yuri. Sorry?
Oh, look, required. Required.
Sorry. Graduated.
For a collision to be
Thank you very much.
Success.
Sorry?
Full.
Scientific error. Excellent.
So it's basically number 3 as well. Okay.
Julia. Overbar. Marina. Heterogeneous.
And I think we're out of time for today, aren't we? Yeah.
Sonia.
So your homework,
Calibrated.
read pages 51 to 54, which is something completely different. Okay, but it's review from last year, so it should be okay. And do pages 54 to 55.
Michaela.
All right. That's why I'm assigning it, because it's something new, but it's actually something old. It's review from Chem 11. Okay. And we'll go over it next day if you have questions about it. All right.
Precision, precision. Andrew. Covalent bonds. Ethan. Yours are all set? Okay, that's all right. Dryden? Same thing. Lance? Volumetric. Yeah, it's okay. By the time we get to the back row, it's a little harder because all of the good ones have been taken, right? All right, Daniel. Valent. Sorry? How do you spell it? What letter does it start with? V? Valence? Valent. Like that? We haven't talked about that yet. No. All right. Max. Scientific notation, yes. Owen. Sorry? Comment. Isaiah. Mantissa. Oh, dang. Love it. One of my favorite words ever. Does anyone have any that have not been said already? Accuracy, yes. Any others? Yes. Sonic device. Not a chemistry word, but a good word all the same. Yes. Pardon me? Overbar. Oh, I think we had overbar. Yeah, we did. But it was hidden way up there, so. Yes.
Section.
Yes.
1.2.
Solution.
No. Yeah, 1.2.
Yes.
Collision theory. So basically, we're going to finish collision theory tomorrow. And then we could have a quiz on Friday.
Oh.
Yeah, let's have a quiz on Friday.
This Friday?
Yeah.
This Friday?
We could go through all our quantities, section?
On section 1.2.
Okay.
Protons and electrons.
Okay.
There's only like one thing. Collision theory, factors affecting rate.
Oh,
That's it.
Oh, okay.
No,
Yes.
no,
Oh,
just
okay,
here.
okay,
Just
okay.
here.
I'm not behind.
Just here, you're fine.
Oh, that scared me.
You're fine, you're fine. There's hardly anything in section
compounds.
1.2.
Yes.
1.2 is easy peasy, okay?
Yeah.
Yeah.
Scared me, but
Sorry?
Tomorrow.
kind of scared. But I'm talking to my kid. I think I might not have screwed up that at
So
least.
we are fast running out of time, so your homework is to start on, I'm hoping that my team will pop up here, is
Okay,
to start
good.
on your vocab list. I will actually make, I'm going to make a master list from all 3 classes and I will post it there after school, okay, on the homework. So you're going to start your visual dictionary. You're also going to study for the counting sig figs quiz, doing page 99 in our workbook, and then the Hebden is optional. You now have that book, take it home and leave it there, okay? Quiz tomorrow, counting sig figs.
Alrighty. I'm going to go say goodbye to Miss Bellier because I haven't talked to her today. So. Oh, but if you have a question,
we'll
yes.
go over the accuracy and precision quiz. So if you're wanting to redo it, you might want to wait until after we've done that unless you're absolutely sure what you did wrong. Okay?
It's neutral, yeah. Yeah, any element on its own, neutral.
Thank you.
Max.
How are you? Where's Sarah? I was like one of those drop here. You remind me, highly mom. You remind me of like.
I'm sorry.
How?
Next day.
I'm not. Like not thinking actually, I can say that, but. It's not. Because this is so
Not people in the class.
like another word nothing.
Yeah, but it's literally the most simple thing ever. That all mistakes I made. We're gonna say it's crazy.
You ain't going. Girl.
No, actually. Yeah,
Sarah, you okay, Sarah.
Oh, yes. Oh, yeah. No, there's more than one. I have at least 2 versions more, and I can make another one if I need to. Questions are all different, right? Every time you do it, different numbers.
No. We're gonna do more dividers.
Underneath the cubby, there's this cupboard you can open. Open the cupboard.
Oh, I see this.
Yes? Because only 2 of them will fit in the cubby.
Where?
Yeah, and then cheating.
And they actually do, somebody gave me a special glove, but I'm not quite sure what I've done with it, and it just has like these 2 fingers, which is really clever, but I don't know what I've done with it. Like I put it somewhere, right? Yeah.
Okay, that's you.
Exactly.
Yeah, so, excellent, thank you.
Oh, imagine why do you put your lip gloss in your face?
Yes.
I'm too tired to teach one more block.
I was thinking like this. No, I want the other.
All right, my friends. What you get to do before you write the quiz is you get to take your phone and come put it up in the cell. Now you guys are green. Last name starting with A is here. It goes over to F, and then F through K, L through O, P through Y, and then there's 2 more Y's at the bottom. Okay. And the only person who doesn't have one is Ellie, but you can just put yours anywhere, okay? I'll make sure I get you on there, but I just haven't updated it yet. And remember, you guys are green. You guys are green.
I didn't bring a calculator. Do you have like a bunch of spare?
Calculator? Yeah.
Thanks.
So I ordered 2. I choose 2.
You're going to get 35 minutes. Not more than 3 minutes. Even my slow my laptop
So.
And I know from grade 11 that we write very slowly was done before 35 years old.
What's like the average
Average was like, right? Yeah. Sorry. Yes, you will want a calculator. I would recommend writing in pencil rather than pen because if you have to scribble things out, it makes it look really awful. Okay? If you have an erasable pen, that would be fine. Or if you're happy using whiteout, that would be fine. But probably pencil is easiest. Okay? When you are finished, this is going to be today's homework. So if you want to get started on it, you can, or you can just relax. Doesn't matter. Okay? After the quiz, and we are going to take 35 minutes to do the quiz maximum. It took nobody longer than 32 minutes last block. Like everybody was done. And I know I had 30 people in there. And I know I have people who were super slow last year. They were like, they would take an hour to do something that would be like a half an hour. So you should be fine. Okay? So 35 minutes is the maximum. Alrighty. And I'm going to start here. Why don't I have two more? No. No, I have them. I promise. I promise I do. Okay, where's the 10, 12. Here's some questions here. Okay. You know what? That'll work. Okay. So you are going to do just the front page. Okay. Just do the front page.
Okay.
And then you'll do questions 6 and 7. Okay.
All right.
Front page 6 and 7. Yeah. And if I manage to find the one without the stuff, then I'll get that for you. Oh no, we're done with it. Oh, yeah. Oh, and just to make life easier for you. Okay. You get rid of this because it